Thank you, Team Discover, for providing me with an opportunity to present my poster presentation. I'm excited to walk you through my poster and thank you in advance for listening. I'm Sneha, a PhD student in the Department of Earth and Environmental Sciences, currently in my third semester. This study was done under the mentorship of Dr. Daniel D. Lee. As the topic of my water speaks for itself, it's about the water quality monitoring. So let's first understand why water quality monitoring is imperative. Water quality monitoring of small inland lakes and reservoirs is paramount as they may sometimes serve as a source of drinking water. However, limited resources for traditional field-based monitoring of numerous lakes, reservoirs covering vast geographical areas often lead to a reactional response of harmful algal bloom outbreak and can cause severe effects on human and animal health as well as disrupt the economies. They are becoming a frequent phenomena in inland lakes and reservoirs due to three reasons. In their nutrient loading from agricultural and urban runoff, increased frequency of droughts and associated reduction in water quantity, ecological regime shift triggered by the external events. Now let's talk about my study area. It is Lake Arlington. It is a popular recreational destination for activities like boating, fishing, and hiking. This lake is a home for many fish species, including largemouth bass, catfish, crappies. In addition to its recreational uses, it also serves as a water source for the city of Arlington. Now let's talk about my data acquisition. That the first thing is imagery acquisition that was retrieved from Sentinel-2. Sentinel-2 is a satellite mission developed by the European Space Agency as a part of Copernicus program. It is a constellation of two identical satellites, Satellite 2A and Satellite 2B, that carries high resolution multispectral images called the MSI. So, as evident from my poster, I have mentioned the date from which date to which date I have uh, tried to capture the images, and my cloud cover percentage is 50%. You have an option of choosing from 0 to 35%. Then for my in situ data monitoring observation, I have taken this data from WQP stored data discovery tool. From the same dates I have used for retrieving the Sentinel-2 image data set by using the following parameters and also and also naming the exact site codes that are used by the USGS. So if you don't put the same site numbers, you might end up getting an error. Now let's talk about my research methodology. So I have here utilized a water quality toolbox in ArcGIS that allowed me to download Sentinel-2 image, and then I processed it, and then I calculated the HAB index and then the performance evaluation. The performance evaluation showed a strong correlation between the data that I received from the satellite Sentinel-2 L2 data and what I got from the in-field monitoring. So when I mapped the two observations, I could get a strong R-square value of 0.89. That shows, that means that this kind of monitoring also has a potential, has a great potential, especially for the locations which cannot be regularly monitored or where regular in-field sampling is not possible. Thank you for your time.